Hello, I'm Ellie, and in this video I will be discussing nuclear reactions, nuclear equations, and radioactive decay. A nuclear reaction is a process that involves changes to the protons and/or neutrons in the nucleus of an atom. The types of nuclear reactions that will be covered are alpha decay, beta decay, fusion, and fission. A radioactive isotope is any isotope that has an unstable nucleus and decays over time. When an isotope is radioactive, it can spontaneously undergo a process called radioactive decay, where an atom emits radiation or a particle from its nucleus to become more stable. The two types of radioactive decay we will discuss are alpha decay and beta decay. Alpha decay is the reaction where an atom emits an alpha particle to become more stable. An alpha particle is composed of 2 protons and 2 neutrons and is the equivalent to a helium atom. It can be written in isotope notation with the helium symbol or the Greek letter alpha. When determining a missing particle, you are essentially finding the values of the particle's mass and proton numbers that will balance the equation. First, subtract 4 from the mass number of the parent isotope to determine the mass number of the missing daughter isotope. In this case, 226 minus 4 is equal to 222. Then subtract 2 from the proton number of the parent isotope to determine the proton number of the missing daughter isotope. In this case, 88 minus 2 is 86. Therefore, our missing particle is radon 222. Beta decay is when a neutron decays into a proton and the atom then emits an electron called a beta particle. A beta particle is written in isotope notation with a -1 proton number and 0 mass number with either an E or the Greek letter beta. Since the mass number of a beta particle will always be 0, the mass number of the daughter isotope will be the same as the parent's, which in this equation is 218. To determine the proton number of the daughter isotope, simply add 1 to 84, which will result in the proton number of 85 and a balanced equation. Our missing particle is astatine 218. Fusing is the joining of 2 smaller nuclei to form one larger nucleus. First, add the mass numbers of the 2 parent isotopes together to determine the mass number of the daughter isotope. In this equation, 17 plus 14 equals 31. Then add the proton numbers of the 2 parent isotopes together to determine the proton number of the daughter isotope. In this equation, 8 plus 7 equals 15. The missing particle is phosphorus 31. Fission is the splitting apart of a large, unstable nucleus into 2 smaller, more stable nuclei. In a fission equation, you will notice that an electron has been added to the parent isotope. This added electron started the fission process by colliding with the parent isotope. You will also notice that 3 electrons are also emitted as a result of fission. First, add the mass numbers of the parent isotope and initial electron. Then add the proton numbers of these 2 particles. In this equation, the sum of the mass numbers of the parent isotope and the initial electron is 236. The sum of the proton numbers of these same particles is 92. Next, add the mass numbers of the given daughter isotope and the 3 electrons, which is 144. Subtract 144 from 236, which will result in 92 being the mass number of the missing particle. Then, add the values of the proton numbers of the given daughter isotope and 3 electrons, which is 56. Next, subtract the proton number of the given daughter isotope from 92 to determine the proton number of the missing daughter isotope. In this equation, 92 minus 56 equals 36. Therefore, the missing particle is krypton 92. The 3 electrons that are emitted in a single fission reaction are important in the start of a chain reaction. First, a high-speed electron slams into an unstable atom. This causes the atom to split into 2 smaller, more stable atoms through fission, while producing a large amount of energy and 3 electrons. The 3 electrons that are produced after the atom splits collide with 3 more isotopes, 1 each. This second collision will cause all of the 3 atoms to split again via fission and emit 3 more electrons per pair of new daughter isotopes produced. This process continues and escalates, creating a chain reaction. In this video, we discussed the different types of nuclear reactions. We discussed how radioactive isotopes undergo radioactive decay through the emission of a particle either by alpha decay or beta decay to achieve stability. We also discussed how 2 small nuclei can fuse together and produce energy. Lastly, we discussed how fission can create chain reactions that generate immense amounts of energy. I hope you enjoyed this video, and I wish you happy studying.